Hi there, welcome back. Remember this? Yeah, I'm sure you do. This was the external BFO that I designed the boards for, that I experimented with, prototyped on, and ended up with this rather unruly mess, and created a new board for. And of course, when you come back from holiday, sometimes you have good news. And this time I do. Look at all this stuff. Look at all this gorgeous stuff. My orders have arrived from Mauser and of course from my sponsor PCBWay, who are again sponsoring this video. They sponsored the last one when I designed the board, and they're sponsoring this one when I get the boards. Now, when I open it up, I have my boards. Beautiful. I've got 10 of them, probably 9 more than I need. But what am I saying? I don't have 10 of them. I've got 20 of them. I've got 20 boards for my external BFO. And the difference between this one and this one is that this one is all through-hole components, and this one is entirely surface mount, or as entirely as can be, because the IF transformers I can't get on surface mount version. So there are a few through-hole stuff, things like the pots, the tuning potentiometers, and the level control. Those are through-hole. Everything else is surface mount. But because I know that you have an aversion, or a lot of you have an aversion to surface mount, this one I'll put aside for now. And the result is I'm going to be working on this board. And I've got all the components here. I have ordered, now obviously some of these are for the small boards, but I've ordered the right value pots. I've ordered, again, a lot of these are SMD stuff, but I've ordered the zero temperature coefficient, what is it called? C0G capacitors. So they are temperature stable ceramics. And I am ready to build this guy. So let's open it up and see what it comes out as. Wow. Okay. Well, that looks pretty good. That looks very, very good. Let's have a look at this. Here's one of my pots. These are the sort of things where you can go wrong. And I didn't. It fits perfectly. Sometimes these mistakes creep in. This time it didn't. I was worried about these pots actually, because I wasn't sure I had the right footprint, but I do. So here we are. I've got all my components. I've got my boards. I'm going to set things up. In fact, what I'm going to do is I'm going to get all the components ready, almost as if this was a kit. And I'll be building this in a logical fashion, which is what you should do. And we'll then be able to test it, and I'm going to build this first version, this first board, exactly as per the result of all the testing I did on this one. As you can see, the board is slightly smaller. I optimized it. Didn't want any excess space because that's sort of wasted and it sort of goes against my compulsive nature. So here, I'm going to get everything ready. And when I'm ready, I'll show you the result of the component selection. And then I'll be able to carry on and build it. And then we'll be able to test it on the scope, and also, of course, on the actual satellite 2100. The one thing on this board is that there is a bias setting here. There's a bias condition, which you set to get the best shaped wave. This is biasing that first transistor. So I'll show you that on the scope when we get to it. All right, let me get things ready. Okay, so everything seems to be about set. I've got all the components marked on here. just made sure that I've got all of them, and the board, and just realized there's a capacitor missing. It's the supply filter cap, the 100 microfarad. Never mind, I'll get that. So I'm going to do this the right way around. Lowest components first, which is obviously the resistors, and build up the board from there. So let me get started. What I like to use just to get the components bent right is this little tool here. Very, very cheap, available just about anywhere. I don't even know what it's called. So there's the first one. I must say this labeling came out just right. I tried to get the legend, in other words the component number, just out of the range of the footprint so that I could actually see it once it's in there, and it came out perfectly. Very happy with this. Let's see if it works. Right, R2. Okay, and I'll just carry on and put in all these resistors, and won't bore you with each one at a time. Okay, they're all in here. I made them all the same pitch between pins so that the bending is the same for each one of them. It's on this row here. And I've got all the resistors in. The only one that's outstanding is actually the bias on here. But that one I will do last because I've actually got to measure. I want to set this at a preset amount before I put it in here. I'm going to flip it over and solder all the resistors. Try not to let them fall out. There we go. Sort of. There we go. Time to solder. I still like doing one pin each so that I can look on the underside and make sure that it's fit properly. So I do the one pin and then I'll flip them over and see if I need to press that pin any further in. Let's have a look. I want to make sure these resistors are in properly, and I can see already that some of them need a bit of a push. There we go. Ow. It gets warm, to say the least. That's it. Now I can just solder all of them, and I'll just reflow the ones that I've touched up on. Those look all done. Solder's flown through to this side, which is great, and it looks good. It is not the easiest thing to do, soldering through a camera lens. It really makes it a lot more difficult. If you've done it, you know what I mean. Okay, so the resistors are done. Now what I want to do is the trim pot is actually replacing the two resistors that bias that first transistor, and the way it works is between 1 and 3. This is the way this trim pot is set. That is 1, 2, 3. In other words, that's the bottom, the middle, the wiper, and the top. And between 1 and the wiper, I need 10K. So what I'm going to do is preset it to, no, I mean 15K. It's 15 and 33. So that's what I need to preset it to. And I'll do that just using the multimeter. This is a 10-turn pot, so we should have quite a bit of precision on here. This will give us this will give us the standard setting as it is on the schematic, and then we can, you see that? Yeah, sort of. Okay. Set that to 15. And then we can adjust it once we have it in circuit. Approximately 15. It's not important that it's too exact. Yeah, that'll do. So I can put that in circuit. But that's actually going to go afterwards because I've got a few low components to put in first. And that would be the Zener diode, 6.8 volt Zener. And where's that one? That's D1. That's over there. Still the same bending criteria. And it's that way around. These boards actually soldered pretty well. No complaints there. So the Zener's in place. What else do we need? What else is small? Well, we've got the varicap diode. I'll leave that actually for last because I can test it without the varicap, but I'll put in the small caps now. And that's what I'll do next. I'll put every capacitor in place, get it ready for soldering, and get back to you. Okay, that's all the 100 nanofarad ones soldered. Let's clear the deck for the next lot. The next ones are actually a bit more critical. So what I'm going to do is, before putting them in, I actually measure them. Just to make sure. I've got a lot of these 100 nanofarad ones. I don't have a lot of some of the other ones. So I don't want to mess it up. Right. Let's carry on. Okay, here's the progress so far, and I've actually found a mistake. Not on the board, not on the schematic, on both. What I did was I'd created the schematic, converted it to PC board, did the layout and everything else, and then I decided at some point to go back and renumber the components to put them in a more logical order. And as it happens, I'd already created the Gerbers before I did that. So the result is that the numbering on these components on the board correspond to the schematic that I had prior to doing the cleanup. Now, doing the cleanup is not important. It just, in my mind, it looked better on the schematic to have the components sort of going up from one end to the other. And the result was I did not do a refresh on the board based on those numbers. So what I had to do is I had to go back and I'd actually put some components in the wrong place, which is why this board is now used. And I started again. So here we are, version 2.1, I suppose. The components are basically, I believe they're all correct. I did some checking. It's a bit confusing when you've got the numbers different on the schematic to what you have on the board. So doing it backwards sometimes works, is a little bit more complex. But anyway, I think I've got that. I've got all the capacitors on here. I've made sure that I've got the right ones because they all look the same. They're all pretty similar, as you can see, these ceramics. All these ceramics are C0Gs, so non-temperature sensitive. They're very temperature stable. Don't need to do that, but I did it anyway. I was ordering those components. It's such a small difference in price that I decided to make them all temperature stable. And I've got the trimmer pot over here. I've already set that lower part to 17 or 15K, the upper part to 30, well, in this case 32K. So it's basically set the way the schematic's supposed to be. I can then adjust it to get the cleanest sine wave that I can. So what do I need to put in here? I still need to put in the varactor diode. I need to put in the IF transformers, both of them, the trim pots and the transistors, and then we're about ready to go. So that's what I'll do next. I'll get back to you as soon as that's done. So here we are. We are completely done, I think. I have fitted the diode. You've got to be careful that you get the polarity right. The varactor diode. Now, I don't recall mentioning it, but the actual diode I've used here is a B910 varactor diode. It's a single, it's not a double. You've got to be careful with the polarity. So the diode works as reverse biased, so you've got to follow the schematic on that one. Other than that, the cans, the IF cans have been put in here. And yes, the cans have been connected to ground. You have to do that separately when you do the board layout because the actual schematic for this doesn't have a connector, a pin, to indicate that the chassis is being connected to ground. The transistors are in place, they fit perfectly, and they actually match perfectly the drawing there on the silk screen. I've got these two plugins, I've put in these headers, as I mentioned on here. It just makes it easy to connect temporarily anyway. The connector for the battery supply or the power supply. I'm going to use 12 volts for now. You've got to be careful here and not do what I've just done. I've just flipped it the wrong way around. I just had, that's positive on the left, negative on the right. The output is also here, and it's RF out on the top and ground at the bottom, but I don't think I'll be using the ground for now, so we've just got that point to monitor. The pots are perfectly aligned, so this would be ideal and quite easy just to fit this into a casing, which I will ponder next. But what I want to do is I want to connect this thing to power, 12 volts. I want to connect a scope to here and see what we get. First of all, there are a couple of adjustments I need to make. I need to adjust this to try and get a nice clean sine wave like we did with, well, fairly clean sine wave like we did with that prototype one. And then I need to adjust this one to get the 460 plus minus 2 kilohertz, and we'll check that as well. So next stage, connect this up to power and the scope as is, and I have not tested it. I want to see what happens. Now, I really am a little bit worried that, you know, this thing worked and this one might not. Nice and pretty and all properly soldered and all that. It's happened before, believe me. I've had prototypes that worked and then you do a nice layout on a board and something's gone haywire. I haven't even cleaned the solder residues from here, the flux residues. I'm just keen to get this thing tested. I have put the jumper on the low output. I have the power supply connected. I have the scope connected. I'm going to give it power. 12 volts. I've got a 50 milliamp limit. Ha 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 ha! Brilliant. Brilliant. Brilliant luck, that is. Okay. Okay. Let's see what happens now. If I... What's the amplitude like? Oh. Okay, it's clipping. 1.26 volts RMS, and it's doing the same clipping thing that it was doing before. That's lowering the amplitude. Let's see, that's a pretty smooth, yeah, it clips there, that's going up. That's the amplitude. I'm just messing with the amplitude level, or the level. And the frequency says 446, 442. That really means very little because I can't read it accurately on there. But let me change it, see if it goes up at all. Did it go up? It seems to be changing. Yeah, it is. 438. It is changing slightly, but I can't really see it too well. I'll have to put up that the frequency counter, which does load this. I know that. So what I'm going to do now, first of all, is I'm going to put this on maximum, and I'm going to try and twiddle the the trimmer pot and see what I get. It's going high. Yeah. That's getting better. Oh, that's too low. I was getting about, I think I was getting about 1 volt, wasn't I? 1 volts RMS, something like that. I've got the amplitude on max, and there's 1 volt RMS. Now that's a pretty decent wave. Pretty much what I had in the last one. And that was fairly easy to do. Literally a couple of turns on the trimmer pot, and we've got ourselves our wave, and we can change its amplitude. And if I put it halfway, this is a log pot. So I've got the pot on halfway. If you look at that, that's 1 volt. Put the pot about halfway, and what do I get? 100 millivolts or so. Yeah, 100 millivolts. So the first half of the rotation takes it to 1/10 of the scope of the range of that pot, which is exactly what I wanted. See, that's pretty smooth from the start. It goes up. Let me change the level there. When it gets to about halfway, then it starts going up a lot faster, and that is very typical with log pots. Logarithmic pots rather than linear pots, and that's what I wanted. There we go. We've got our pot. We've got our wave at 1 volts or thereabouts. 997. This scope is not exactly the best at measuring amplitudes. It depends on how many waves you got on the screen there. 984. If I want to really go finicky, I can just give it a little bit more. There's 1 volt, and it's still a nice wave. Okay, and it's drawing 30 milliamps at 12 volts. Now what happens if I drop that to 9? There's 11, 10, 9. And we have 823 millivolts, perfectly usable, from a 9 volt battery. What happens if I go to 8, 7, 6? Now, somebody asked what would happen if they wanted to use this thing with the batteries that come in a radio itself. I'm sure you can do a lot more. Actually, what I'm going to do is I've got it down to 6 volts. I'm going to, I can always adjust it back, play with the trimmer. And it starts clipping there, but before it clips there, I've got 500 millivolts usable. That's not bad. That's not bad at all. In fact, what have I got if I change this thing to high? I'm going to change this from low to the high setting and see just what usable wave I have there. If I want to use this from batteries, that's off and that's the high. There we go. Okay. Bloody hell, this is brilliant. It's 2.8 volts RMS. Clean wave. There's the amplitude control. Amplitude on maximum. 2.8 volts. That's the high setting on this. And that is with 6 volts. Now what happens if your 6 volt battery starts wearing down? Yeah. You lose it. How far can you go before you lose it? 5.6 volts, 5.5, 5.4, 5.3, 5.2, 5.1, and at 5 you lose it. 5.1, you're okay. You got 750 millivolts. I don't know how much power that would give you, but it looks like you can bring your battery down to about 5.5 volts, and you've still got a usable signal there, which is controllable by your with your level pot. Now, ideally, what you should do, if you want to do this, you should use a 5-volt Zener. In other words, you should stabilize the biasing on that first transistor purely for a fixed 5 volts, for example, instead of having a 6.8 over there. So yeah, you could do that. You could change that Zener diode to 5 volts. It's obvious that the booster stage works quite well. The buffer works quite well. All it does is it affects your amplitude. But it seems to work quite well. So yeah, why not? The question was, can you set this up to work on 6-volt battery, which is what most of these smaller transistor radios use? The answer is yes. Now, I did adjust it. Oh, that's the high one. I'm going to put it back on low. This is now on 12 volts. High gives me 6 volts RMS. But I want to put it on low, and I want to clean up the wave and then see how much we get on high. There's our low. It's got a bit of clipping on there. And there's our 1 volt over here. Now if I take it to high, just changing the... Now remember, this change you can use a switch as well, just a single pole, double pole, single throw. Single pole, double throw, sorry. In other words, select A or B from a switch, and you get 5.2 volts peak over there, maximum, that you can use. Okay, that's the first thing done. Now we need to adjust the frequency and see how good that is. And for that, I'm going to set up that rather low impedance input, super high-tech frequency counter, bought on eBay for about $5. Be right back. I've connected that up to here using a scope probe, 10-to-1 scope probe, and it seems to obviously drain less, load it less. So the actual sine wave there doesn't look so bad. Now I'm going to adjust this guy here to get, well, what do I need? I need 460 plus minus 2 kilohertz. Let's see what the range is like. Going up. It's 461. I've got this thing on max. So 461.27, call it 461.3, is the upper range. If I go down, 456.8, 4.5 kilohertz, 4.56.9 actually, 4.3 kilohertz, either way. So what I can do is, actually I'll put it at the top end, and I will give it half of that, so 2.1. So I want 462.1 on there. Too much. It's probably a little bit too much. This is very sensitive. Too low. $462.3. Let's see what happens the other way. If I turn it to minimum. Yeah, 457 point, what is that, 8? 457.8. So I've got 2.2 below, and 2.2 kilohertz below 460, and 2.3 above 460. That, my friends, is as near as damn it perfect. And it seems to be pretty stable. Let me just put it at an arbitrary point over here. It's not bad. Just make it go faster. So 461.5354. There's my 460. And it's not obviously in the middle because this the diode is not linear. I have shorted out that resistor R10, that is the one that goes to the tuning pot. In other words, I'm giving the full 6.8 volts to the trimmer, to the tuning pot. If I had 9.1 as the schematic called for, then I could probably have got away with having that 39K resistor, which would act as a voltage divider really between it and the pot and reduce the span of that diode. But what I've done instead, because I've got a lower voltage, is I've increased the capacitor that couples the diode capacitance to the tank circuit. That's why that became 330 picofarads, or 330 picofarads. And that was just to get the right range between the span of voltage that I have here and the corresponding capacitance that the varactor would give me, and pass that on to the tank circuit, which has as a fixed capacitor 50 picofarads. All right, I'm happy with that. And the wave, which I'm seeing up there, is pretty good. Now that seems to be pretty stable. As you can see, it's been flicking around for a while, but not much. There's our 2.2 low and our 2.34 above. Now, obviously I can adjust that, but I'm pretty happy with that. I'm very happy with that. Thank you very much. Right, time to test this on the actual radio. And to do that, I'm actually going to fit a battery, a 9-volt battery. I want to make this as complete as possible. And I'm going to fit a 9-volt battery. And I'm also probably going to fit a little wire. I don't need to screen it or anything, because remember, you're trying to bleed IF frequency onto the radio. So you don't have to worry about it leaving anywhere. Not too much anyway. And also these are grounded, so they're pretty well shielded. And I'm going to fit a wire with probably just a crocodile clip, so that I can clip it to various parts of the Satellite 2100 and see where it works best. Testing time, and the objective afterwards is to see, whether I put this thing into an enclosure, how much trouble I go to make this a permanent fixture. I'm very, very happy with the result so far. Let's see how it works in practice. Right, we're going to try the 40 meter band. I've got it here in the band spread. Here we've got something, so that is on. I can see the strength of whatever I'm feeding over here. If I take it up, it obviously brings in the AGC and reduces the noise. Now I just there you go. As long as you understand Spanish. Let's try something else. Here's another one. Got to increase the level. There we go. And I'm using the 9-volt battery, and it's on high actually. I put it on high because it gives me a better spread here.
y el receptor de radio, entonces cualquier modificación yo no tengo la actualización del router para apertura de puertos de interno por email. Yo tengo pedido qué es lo que me tienen que tener abierto y cada puerto a qué programa tiene que ir y funciona correctamente.
Now that, if you understand Spanish, is perfectly discernible. And I can leave this here for ages, and as long as they keep talking, this thing's stable. There it is. Some CW. Now you have to bear in mind that if you increase the level, you're actually decreasing the sensitivity. So the AGC, the automatic gain control, is actually stepping in and dropping the gain of everything. So what happens is, if you go to a strong signal like this one, you see, when I take that up, I'm increasing the level of the carrier that I'm feeding into there. And it's great because you can hear it. The problem is, if this guy is sitting next door to you and you set the level so that you can hear him properly, and the guy he's communicating with is somewhere on the other side of the ocean, you probably won't hear his response, right? Because you would have to lower this, and that you'd leave the same. You'd have to lower it to make sure that his signal can get amplified through. That happens with most cases anyway. And this is it. And it's been working from a 9-volt battery all the time. I've clipped this to the antenna first of all, and it works because when you select external antenna on the satellite 2100, it actually shorts the internal antenna to ground. So what you're doing really is you're connecting this to ground. And so what I decided to do is to just find a ground point, which happened to be the handle, and I connect this to the handle. It actually works better. What's happening is you're feeding this to the chassis ground. Because everything is floating, it doesn't really make any difference. There are a lot of ground points that come close to the sections of the radio that would pick up this carrier. So I've actually found on this particular guy, the easiest way to get a signal is use the ground. But connecting to the antenna also works. Bear in mind, these things have got IF traps. In other words, there's well, it's built in a blocker, a trap for 460 kilohertz, which is not supposed to get in through the antenna because you don't want to let it go through. You want it to be produced internally. Because the signal here is so high, I mean, in some cases you can go as high as 5 or 6 volts. That'll get straight through there, but it's never necessary to go that high. I just put it where it's needed to give me the closest or the clearest signal. So this guy works very well, and I'm happy to say. So what I'm going to be doing is this. I'm going to publish the Gerbers for this, together with the updated schematic. When I say updated, all the numbering will be correct. And I'm going to publish it or share it on the PCBWay shared project section. So you can actually just order from there. However, this is not the end of the story. This one works. I've made no changes to it from the prototype stage, and I'm happy as a pig in mud. But I'm going to do a next one, which is the SMD version, the surface mount version, and I'll be publishing that one as well. So if you want to build this one, go ahead. The Gerbers will be on the share section. I'll share it with you. I'll list it below in the description. If you want to wait a bit and see how the surface mount version works out, be my guest. I'll be doing the same with that one. All right, I'm going to be playing a bit more of this, and I will see you again soon. I've got quite a lot going at the moment. I'm waiting for that FM section for the GRUNDIG 4006. I want to get that one going. I have a TELEFUNKEN, small TELEFUNKEN on its way, which is a gift from one of my subscribers, Bob, so I want to thank him for that. When that comes in, that's certainly going to take priority. I love those small sets, tube sets. And this one is a TELEFUNKEN, which just makes it even better. If you've enjoyed this, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links at the end of the video and in the description below. Thanks for watching. Stay safe.